In this video, let us see about the Kirchoff's law and we will solve the problems using mesh analysis. There are two Kirchoff's law, namely the Kirchoff's current law and voltage law, and it is named after Robert Kirchoff, who found these laws. So this Kirchoff's current law is called as Kirchoff's first law, and Kirchoff's voltage law is also called as Kirchoff's second law. Let us see about the Kirchoff's current law. According to this law, the algebraic sum of the currents meeting at a junction or a node is 0. For example, you take this node. So here you see the direction of arrow in I1, I2 and I3. They are entering the nodes. So sum of the currents entering the node is I1, I2 and I3. You see the arrow direction of I4 and I5. They are leaving the node. So sum of the currents leaving the node is I4 plus I5. So what does this current law says? Sum of the currents meeting at a node is 0. So I can write I1, I2 plus I3. I4 and I5 are leaving the node. So its direction is taken as negative. So minus I4 minus I5 equal to 0. Or I can write it as sum of the currents I1, I2, I3 entering the node is equal to sum of the currents leaving the node. So this is Kirchoff's current law. We will see about the Kirchoff's voltage law. You take any closed path or a loop where the sum of all the voltages is equal to 0. So if you take this circuit, there is a voltage source and two resistors are there. When current passes through the resistor, there will be a voltage drop. So V1 is equal to I into R1, and here you have a voltage drop of V2 when current passes through this resistor. So according to this law, the sum of all the voltages V1, V2 is equal to 0. But the important thing to note here is what is the polarity of each voltage. So if you take a voltage source, if you start from this point, let me start from this point, I am moving in this direction, or the current is moving in this direction. I am moving from negative polarity to positive polarity, that is minus to plus. It means that it is a rise in potential. So I should take this as plus V. When you come here, the same current is flowing here now, and you can hear it is see here it is marked as plus minus. What it shows that the current always flows from higher potential to lower potential. It is similar to water. A water will flow from a higher level to lower level. Similarly, current will always flow from higher potential to lower potential. So if you current is flowing in this direction, so this is a drop in potential or fall in potential. So I should consider the polarity of V1 to be negative. Similarly here, the same current is flowing from this end to this end. So plus to minus, it is drop in potential. So it should be minus. So when I write the whole equation, I am moving from this edge. Okay, I am starting from this point. So it is rise in potential minus fall in potential minus fall in potential is equal to 0. Okay. This sign convention is more important because if you change the polarity, the whole equation becomes wrong. Okay. When you move from negative to positive, it is considered to be positive because it is rise in potential. When you move from plus to minus, it is minus V1 because it is fall in potential. Okay. Let us see how to solve the problems using mesh analysis. Actually, there are two types of methods. One is called mesh analysis, another one is node analysis. What is mesh analysis? You have to identify the mesh and write the mesh equation. In nodal analysis, you have to identify the nodes in the circuit and write the nodal equation. So in this video, we will be seeing only about mesh analysis. So this mesh analysis is preferred when you have more voltage sources, and nodal analysis can be used when you have more current sources. Let us consider this circuit where you have two voltage sources. So we can go for mesh analysis. And first let us find how many meshes are there. So this is a mesh. So this is one and this is the second mesh. So you identify the mesh, then mark the current direction. So you always take the current direction in clockwise in both the meshes, so that it will be easy to write the equation. It is not necessary that you should always take the current in this direction, but you prefer taking in this same direction, so that when you apply Cramer's rule, it will be easy. So first thing, you identify the number of meshes, then mark the current direction. So now we have two unknown variables, I1 and I2. So you have to write two equations. So one equation for mesh 1 and the other equation for mesh 2. Now let us take a problem and write the equations. The first problem is find the current through the 3 ohm resistor. So in this circuit, you have a 3 ohm resistor in the branch BD. So what you have to do is find the current through this 3 ohm resistor. So let us find the number of meshes here. 2 meshes and 2 currents are there, I1 and I2. So what you have to find is current through 3 ohm resistor. So we have considered I1 is flowing like this, I2 is flowing like this in opposite direction. So the current through 3 ohm resistor is I1 minus I2. So number of meshes is 2. What are the meshes? A, B, D and A. This is first mesh. Second one is B, C, D, B. This is second mesh. So you will get two equations. If you solve these two equations, you will get what is I1 and I2. So let us write the first equation. So take the first mesh A, B, D and A. So you start from D. Okay, let us start from D. So here you have negative and positive, a 42 volt source. So when you move from D to A, that is current is moving from lower part to higher part, from negative to positive. So it is a rise in potential. Rise in potential means you have to take it as positive. So plus 42. And in this branch, current is flowing from plus to minus, or current is flowing like this. So it is a drop in potential. Write it as minus 6. What is the current through this resistor? I1. So minus 6 I1. So when you are coming through this branch BD, you write it as minus 3 into, what is the current through this resistor? I1 minus I2. So you write minus 3 into I1 minus I2 equal to 0. So we are applying Kirchoff's voltage law. According to Kirchoff's voltage law, sum of the voltage drop equal to 0 in any closed loop. So in this loop, sum of the voltage is 42 minus 6i minus 3 into current through this 3 ohm resistor equal to 0. So let us simplify this one. So 42 minus 6i minus 3i1 plus 3i2 is equal to 0. So you will get this one. So always if the first part is having negative, multiply by minus 1, it will be easy. You will understand why I am telling this one. When you solve the equations using matrix method, that will be easy. So 9i1 minus 3i2 equal to 42. So next, take the next loop, this one B, C, D, B. Let us start from this B point. So current I2, you see the current direction, it is going like this. So I can write minus 4I2, and in this branch it is negative to positive. So plus 10, and here your I2. So you forget about this loop 1, you see only the loop 2. So I2 is flowing from D to B. So I am writing minus 3 into I2 minus I1. Either you can write plus 3 into I1 minus I2, or you write minus 3 into I2 minus I1 equal to 0. Simplify this one, you will get the second equation. So now you got two equations. Now you got the two equations. Now you can apply any method and solve these two equations and find what is I1 and I2. You can use determinant method, or you can write the equation in matrix form and solve it, or you can directly solve the equation. So I am going to solve the equation. See here, this is 9i1 and this one is 3i1. So it is easy to eliminate i1 first. So for that I am going to keep the equation 1 as such and multiply this second equation by 3. Okay, because if I multiply this equation by 3, I will get here 9. So 9 get cancelled. So I am multiplying the equation 2 by 3. So it becomes 9i1 plus 7 into 3 is 21i2 is equal to 30. So I got the third equation. Now with this equation you add first equation. So if you add these two get cancelled and you can find what is I2. Now you substitute this I2 in any of the equation. You take this first equation, you substitute the value of I2. You can find what is I1. So you can find what is I1. So what is the question? You have to find the current through 3 ohm resistor. So the current through 3 ohm resistor is I1 minus I2. So it is equal to 2 amps. In case you have taken the current in opposite direction, that is, instead of taking I2 in this direction, if you have taken it is in opposite direction, what happens is you may get your answer in minus. It means that your assumed direction is just opposite to the actual direction. There is nothing wrong in it, but while writing the answer, you write the correct polarity. That is enough. So always prefer to take the I1 and I2 direction in clockwise, so that your equations will be very easy and it is easy to solve. Now let us solve another problem with 3 meshes. So in this case you have I1, I2 and I3. So three meshes are here. So you need three equations to find the value of I1, I2 and I3. Now first identify the meshes and you mark the current directions I1, I2 and I3, and then mark the variables A, B, C, D, E. Okay. Now you take one loop at a time. I am taking the first loop, that is A, B, E, D, A, this loop. Now we will apply Kirchoff's voltage law and write the mesh equation. Let me start from this point D. You see the current direction, it flows from minus to plus of 7 volt. So negative to positive means it is rise in potential. So let me write it as plus 7. Then when you come from this, that is this current is flowing like this, and when you come from top to bottom, that is in BE branch, you write it as minus 1 because it is a resistance. You write it as minus 1. What is the current in this branch? I1 is flowing in this direction, whereas I2 is flowing in opposite direction. So write it as I1 minus I2. And next when you come here, the voltage is plus to minus. So plus to minus means it is drop in potential or fall in potential. So take it as minus 6. And through this 2 ohm resistor, what is the current? I1 is flowing in this direction, whereas I3 is flowing in opposite direction. So take it as 2 into I1 minus I3 equal to 0. So now you have written the equation, first equation. You simplify this, you will get the first equation. Now let us take this loop, second loop, B, C, E, B. Okay. Let me start from this point B. You see the current direction. So it is minus 2 into, what is the current through 2 ohms? Only I2 flows. So minus 2 I2. And again minus 3 into, what is the current in this branch? I2 is flowing like this, whereas I3 is flowing in opposite direction. So here I2 is flowing in this direction, whereas I3 is flowing in opposite direction. So this current. So it is I2 minus I3. And if you take the next one, 1 ohm resistor, your I2 current is flowing. So you take here as minus 1. What is the current in this branch? I2 minus I1 equal to 0. You remember one thing, when you have a voltage source, you see the polarity of the voltage source, that is in which direction current is moving. Minus to plus means take it as positive, whereas it is going from plus to minus means take it as negative. Whereas in case of a resistance, always you see, if you are writing for loop 1, take that current as first part. Okay, first variable should be that current. For example, in case of loop 1, you write I1 minus I2, whereas when you write for loop 2, you make it as I2 minus I1. Okay, and this resistors, all the resistors will have a negative sign. Okay, now you can simplify this second equation. Then third equation, you take this loop E, C, D, E. So in this case, let me start from this point C. So here current flows, I3 flows through 1 ohm resistor. So minus 1 into I3. through this 2 ohm current is I3 minus I1. That is, you are in third loop. So take I3 first. I3 minus I1. Then you have a voltage source. You see here you are moving from negative to positive. So it is a rise in potential. So take it as plus 6. Then you are moving in through the 3 ohm resistor. Here you should write minus 3 into, you are in third loop, so I3 minus, what is the other current? I2. I3 minus I2 equal to 0. So you simplify this, you will get three equations. Now you have to solve all the 3 equations. Now we have got all the 3 equations, then solve our equations. So this is the first equation and this is second one. So it is easy to eliminate the I1 variable first, because if I multiply the second equation by 3, I will get 3I1, so I can cancel these two easily. So I am going to multiply the equation 2, this equation, by 3. So I will get 3I1 minus 18I2 plus 9I3 equal to 0. Now add this equation with the first equation. So what happens when you add these two? I1 gets cancelled and you will get an equation in terms of I2 and I3. Now you need one more equation to solve this equation. So what we can do is take the third equation, and you see here you have 2I1. So if you want to eliminate I1, I have to multiply this second equation by 2. So let me multiply this second equation by 2. I will get 2I1 minus 12I2 plus 6I3 equal to 0. So you put, since you subtract these two, because this is 2I1, this is 2I1. So here you can subtract these two. So I have given the symbol minus. So this minus will become plus and this plus will become minus. So if you simplify this one, you will get another equation and mark it as 5. So now you got two equations and two variables are there, I2 and I3. Now you have to solve these two equations to find what is the value of I2 and I3. So now let us eliminate I2 from this equation first. So this is 17I2, 11I3 equal to minus 1. So what can I do is, I am multiplying the fourth equation by 15. Here 15 is there. And the fifth equation you have to multiply by 17, so that you can easily eliminate I2. So multiply the first equation, that is fourth equation, by 15. So this is the equation, and multiply this equation by 17, you will get this equation. Now you have minus 255 here, plus 255 here, so you add the equation. So these two get cancelled and you will get the answer for I3. So I3 is 3 amps. Now you substitute this I3 in any one of the equation. Okay, so let us substitute here. So put I3 is equal to 3, you will get the value for I2. Now this I2 and I3, put it in the second equation, you will get what is the value for I1. So this is how you have to solve the equation. But if you know to solve by matrix method or using calculator, if you can solve the equation directly, it is good. But these are the steps to solve the equation. And while writing the answer, always specify this amps. If it is current, always specify the unit as amps. And if we are finding some voltage, mention it as volts. So this, for this circuit, this is the answer. So the points to remember here are, Kirchoff's first law is the Kirchoff's current law. The algebraic sum of the currents meeting at a junction is 0. Kirchoff's second law or the Kirchoff's voltage law. According to this law, the algebraic sum of all voltages in a loop is equal to 0. And you should be well versed in the sign convention, that is where you have to take it as positive sign and where you have to take the voltage as negative sign, because that will change the whole equation. Always rise in potential, you take it as positive, and fall in potential, take it as negative. And if you like the video, do subscribe to Read Electric Vehicle channel. Thank you. These are some of the references I have used.